What's up, everybody? Hope you guys are doing well. Welcome to your very last geometry lecture video. You guys made it.
Bobby Yamamoto.
Real quick, I want to do a run through of the whole week material and a little bit into next week as well, what's coming up and what you guys need to get done. You guys have 4 things left to do. One, you have to complete the 13.5 homework by midnight tomorrow night. Two, you guys will have a quiz this Thursday on sections 13.1 and 13.2. That quiz will start at 10 a.m. for the first group, noon for the second group. If you're in the second group, I'll send you an email. If you need to be in the second group, make sure you send me an email and I'll put you in the second group. If you don't receive an email from me, you're taking it at 10 a.m. on Thursday, the quiz on 13.1, 13.2. Thirdly, I think that's a word, thirdly. Now, third thing you guys have to do is finish the final study guide. Now, the final study guide, that's like our final assessment. That needs to be done by the 12th, which is next Tuesday, and you guys have to treat that just like you would any homework assignment. You have to show all of your work, do all the problems, and if you do that, turn it in on time, midnight by Tuesday night, the 12th, that's next Tuesday, you guys will get full credit, but that will go into your classwork category. So that will go into your classwork category, which is 10% of your grade, which is pretty significant. So make sure you don't slack on that, make sure you get it done, and that's just going to be our way to wrap up the entire semester. Now, last thing we have to do, our fourth thing that we have to do, is you will have a test next Tuesday, which is the same day as the final study guide is due. But next Tuesday, the 12th, at 10 a.m., you'll have a test on chapter 12 and 13. So make sure that you guys are studying for that, and I kind of worked it out for the final study guide that Monday before the test. You guys will be doing the chapter 12 and chapter 13 parts of the study guide to kind of prepare for the test. But that's when our test is next Tuesday at 10 a.m. for everybody, unless you're in the second group, which will start at noon. So that's our 4 things. Homework 13.5, quiz 13.1, 13.2, Thursday 10 a.m. 3, final study guide due next Tuesday at midnight. And fourth, we have a test next Tuesday at 10 a.m. on Tuesday at 10 a.m. Tuesday 10 a.m. Tuesday 10 a.m. Tuesday 10 a.m. Don't forget that. But other than that, we're almost there, guys. Enjoy the lecture, the last lecture. See ya. Alright, so today we're looking at section 13.5, and we're actually going to be skipping 13.4. So ignore 13.4. We're just going to go straight to 13.5. So to start with, let's look at compound events. These examples will kind of be a review and will lead into our next section. So let's say that the math club sponsors a booth at a school carnival. Visitors to the booth can win prizes by spinning this wheel here. Now, let's find each probability first, and remember, the probability of your event is equal to what you want over the total. So example 1, find the probability of the wheel landing on an odd number. So for number 1, we're going to be looking at the probability of an odd being spun. Well, what's our total? What's our total sample space? We have 12 numbers. And how many of those numbers are odd? We have 1, 3, 5, 7, 9, 11. So 1, 2, 3, 4, 5, 6 out of 12, which reduces to 1/2. So the probability of spinning odd is 1/2. Number 2, what's the probability that the wheel lands on a multiple of 4? So say probability of a multiple of 4. We still have 12 sections total, but what about multiples of 4? Where we have 4, 8, and 12, so that's 3 out of 12. That reduces to 1/4. Number 3, what's the probability that the wheel lands on a prime number? So say probability of prime, we still have 12 spaces total. How many of those sections, those numbers are prime? We have 2, 3, 5, 7, and 11. So 5 out of the 12 spaces are prime, and that is our probability of spinning a prime. Quick note, 1 is not prime. Common mistake there, because basically it has to be prime, it has to be any positive integer that's divisible by exactly 2 positive integers, itself and 1. So basically 1 and itself, and it can't be 1 twice. Just a quick explanation there. You can't repeat your number to be prime. Number 4, during the morning, a player can win a prize if the player's spin lands on an odd number, or, keyword there, or a multiple of 4. Which numbers result in the player winning the prize? Now this is the intro into our compound events. Notice the or. Now, in yesterday's lecture, we were looking at and events. Both had to occur. Like I'm spinning a 2 and it has to be prime, or something like that. I'm rolling 2 dice, it has to be blue, and it has to be prime. Both events, we're looking for the probability of both events occurring. With or, this is either or. I don't care which one happens, just one or the other. So that's what our compound events are. Now, example 4 starts with, in the morning, a player can win the prize if it lands on an odd number or is multiple of 4. So which numbers result in the players winning a prize? So right now let's just look at what actually satisfies as a winning spin. So an odd number, well, we have 1, 3, 5, 7, 9, and 11. So we have 1, 2, 3. So say odd. We have 1, 3, 5, 7, 9, and 11. And then multiple of 4. Well, those are just 4, 8, and 12. So that's what question 4 is asking. Which numbers actually satisfy the winning condition? Number 5, what's the probability that the player will win a prize in one spin? Well, to do this, what we're going to be looking at is the probability that we get an odd number or a multiple of 4. Well, what is our total? Our total is still 12. We still have 12 spaces total. Well, how many numbers are winning numbers? Well, we have 1, 3, 5, 7, 9, 11, 4, 8, and 12. So we have a total of 9 numbers. So we get 9 over 12, which reduces to 3/4. Now one thing we do have to be careful of when doing this, and this case was fine, we didn't have this occurring, but we have to check for repeating numbers, or repeating events. Now notice in the odd and multiples of 4, I had 1, 3, 5, 7, 9, 11, and then 4, 8, 12, I didn't repeat any numbers. So since there's no repetition, I could calculate the probability fairly easily. But let's look at, I'm going to erase this, so pause the video if you haven't finished writing. But let's look at number 6 and 7. Number 6 states, during the afternoon, a player can win a prize if the player's spin lands on an odd number or a prime number. Which numbers result in a player winning a prize? So odd, we still have 1, 3, 5, 7, 9, and 11, or a prime number. Now our prime numbers are 2, 3, 5, 7, and 11.
notice the repetition here and here. So if all those numbers being repeated. So I don't want to double count. So that this would be the answer for number 6. But number 7, where we calculate the probability that it's odd or prime, we don't want to repeat our counting. So what we're going to do is just count each number only one time. So I get 1, 2, 3, 4, 5, 6. Don't count that because it's repeating. No, no, no. But then I will count that 2 because I haven't already counted it. So we get a total of 7 out of the total 12. And that is the probability that you would spin an odd or a prime. Now compare that to what we did yesterday, the AND. That was different because I'm looking for both to occur, or I'm looking for either or. I don't want to repeat my counting. And the AND, remember, that was where you would have to assume one did occur and then look for the second one. So that is our compound events. And a few terms to fill in. Whether we're the two possibilities of winning events are in the morning are mutually exclusive, so that's our first term, and mutually exclusive events cannot both occur in the same trial of an experiment. So we have a few different things here. We have simple events. A simple event describes a single outcome. Compound events. A compound event is made up of 2 or more simple events. So a simple event is what's the probability of picking a heart in a deck of cards. You're 52. Compound events would be what's the probability of picking a heart or a king. Heart or king. That would be your compound event. Now, mutually exclusive events, that's our next one. Mutually exclusive events are events that cannot both occur at the same time. So a really basic example of what a mutually exclusive event would be is, let's say, even and odd. If you pick a number, it's either even or it's odd. It can't be both at the same time. That's an example of a mutually exclusive event. You can't have a number that's both even and odd at the same time. It has to be one or the other. Now, inclusive events are events that have one or more outcomes in common. So an example of inclusive events would be, let's say, even and prime. So what's the number that's both even and prime? Well, 2. That would be an inclusive event. So those are both as simple as possible examples that I could think of to explain mutually exclusive and inclusive events. Now, our first term here, mutually exclusive. Exclusive. We're going to say that the probability of 2 mutually exclusive events, A or B, occurring is the sum. So we're going to add their individual probabilities. Now, if we were to look at Venn diagrams, remember Venn diagrams is typically where you just take a circle and you look at the 2 events occurring, see what's in common. So this would be mutually exclusive events because this is the universe of the first event happening. This is the second universe. Notice that there's no overlap, so there's no way that both can occur at the same time. Now compare that to, let's say, inclusive events, like what we have here. When there is overlap, that would be, here's event A, event B occurring. This would be both occurring at the same time. So this would be inclusive. But with these, with the mutually exclusive, we're going to add or take the sum of the individual probabilities. So for two mutually exclusive events A and B, we're going to say that the probability of A or B occurring is equal to the probability of A plus the probability of B. So or means add, and means multiply. That's a little trick there. When a number, so our example, when a number cube is rolled, the probability is less than 3. So for this example, we're going to say, what's the probability of rolling it on a die, a number that's less than 3? Well, what's our two options? We have 1 or 2. So when we say less than 3, I don't care which number I get, I just want one that's less than 3, so that's 1 or 2. That's my two options. So since this is an or, this is mutually exclusive, I can't roll both at the same time, looking for either or, I'm going to add the individual probabilities of rolling a 1 or rolling a 2. Well, that is going to give me 1 over 6 plus 1 over 6 gives me 2/6, which is equal to 1/3. So that's a very simple mutually exclusive probability. Now for inclusive, we're going to say that the probability of two inclusive events, A or B, and again notice that this is or, A or B occurring, is the sum. Again, we're going to add the individual probabilities, but we're going to have to subtract or minus the probability of both occurring. And this goes back to this example here, 6 and 7, where we didn't want to double count the repeating numbers. So when we don't want to double count the repeating numbers, we're just going to subtract it away. That's how we'll mathematically take care of that problem, which is basically what we did here. I didn't actually subtract it away, just crossed them out. So our algebra, we're going to say that the probability for a inclusive event, A or B occurring, is going to be equal to the probability that A occurs plus the probability that B occurs. We're going to subtract the probability that A and B occur. So this subtracting the A and B, that's the repeating. Right there, that's the minus the probability of both occurring. So you don't want that repetition to occur. So the example given here, when you roll a number cube, what's the probability that it will be even or prime? Even or prime. So when we look at our Venn diagram, and these are really helpful to see. So even or prime, that's our two options here. I'm explaining this Venn diagram here. So we have even or prime. Well, let's look at, this will be event A, which we'll say is even. And we also have the prime event over here. Now on a number cube or a die, we have the numbers 1, 2, 3, 4, 5, and 6. Well, how many of those numbers are only even but not prime? So only even. Well, we have 4. 4 is even but not prime. We have 6, even but not prime. Which of these numbers are only prime, but not even. We have 1, 3, and 5. Now, which of these numbers are both? So right here, this is the both, even, and prime. Well, we have 2. So that is our Venn diagram right here. And the symbol for the symbol right here, the like upside down U, that's and. We'll just and. If it's like this, that's the union. So this is intersection. That's union, and that means or. So that's just some set notation there. So the probability of rolling even or prime, what we're going to do is calculate the probability of rolling even, add it to the probability of rolling a prime, or then we're going to subtract the probability of even and prime. Well, what's the probability of rolling an even number? Well, again, 1, 2, 3, 4, 5, and 6. The probability of rolling even is 2, 4, and 6. 3 out of 6. The probability of rolling prime, we have 1, 2, 3. Oops, sorry. See, I made that mistake. Not 1. 2, 3, and 5. So 3 out of 6. What's the probability of even and prime? Well, that's this part right here. That's the intersection. That's both occurring. Well, that's only 1 out of the 6. So what this will give me is 6 over 6 minus 1 over 6, which gives me 5/6. So if you're looking for either an even number or a prime number when you roll a die, the likelihood, the probability that you'll get even or prime is 5/6. Let's do a few more examples. Ben rolls a 1 through 6 number cube, find each probability. So again, we're just rolling a die, looking for the following probabilities. First, Ben rolls a 3 or a 4. Now let's ask ourselves, is that mutually exclusive or is that inclusive? The question you have to ask yourself is, can I roll a 3 and a 4 at the same time? No, you can't. So this would be mutually exclusive. So the probability of rolling a 3 or a 4 is going to be equal to the probability of rolling a 3 plus the probability of rolling a 4. Well, that's going to be 1/6 plus 1/6, which gives me 2 over 6, which reduces to 1/3. Number 2. What's the probability that Ben rolls a number greater than 2 or an even number? Well, is that mutually exclusive or is that mutually inclusive or inclusive? Well, the question is, can I roll a number that's greater than 2 and be even? Yes. Can I roll a 4? So this would be inclusive. So the probability of rolling a number greater than 2 or even is going to be equal to the probability of rolling a number greater than 2 plus the probability of rolling an even number minus the probability of rolling a number greater than 2 and even. Well, that's the probability of, so let's look at probability of rolling a number greater than 2. That's going to be equal to, well, what number is greater than 2 on a dice? 1, 2, 3, 4, 5, and 6. 3 through 6, so you have 4 out of 6. What's the probability of rolling an even number? We have 2, 4, and 6. So 3 over 6. what's the probability of both occurring, number greater than 2 and even. Well, number greater than 2, those are out, has to be even, those are out, so you have 4 and 6. That's going to be 2 over 6. So all we're going to do is to find the probability of a number greater than 2 or even, we're just going to add those up. 4 plus 6 plus 3, or 4 over 6 plus 3 over 6, and then subtract away the repeating or both occurring. Well, that's going to give me 7 over 6 minus 2 over 6, which gives me, I come up here to finish, your solution, which is 5 over 6 again. Now, if you want to draw a Venn diagram to help you understand this one, we have greater than 2 or even. 1, 2, 3, 4, 5, and 6. So drawing our Venn diagram, let's start with numbers that are only greater than 2, but not even. Well, that would be 3 and 5. Now let's look at even. Which numbers are only even, but not greater than 2? Well, that'd only be 2. Now, which numbers are both greater than 2 and even? Well, that would be 4 and 6. So in calculating the probability of this sphere, you have a total of, you can just count 1, 2, 3, 4. So you have 4 out of the total 6. Plus, let's look at this Venn diagram, or that circle. 3 over 6. Now let's subtract away numbers in the middle, which is 2. So 2 over 6. And that will give you the 5/6. So that's another way you can do it, by looking at the Venn diagrams, using the Venn diagrams. Let's do number 3. So we had 5, 6 for that one. Number 3, what's the probability that Ben rolls a prime number or an odd number? So prime or odd. Now will that be inclusive or exclusive? Can you roll a number that is prime and odd? Well, yes, so this would be an inclusive probability. So let's look at let's do this one with Venn diagrams. So we have prime, and we have odd. So which numbers are only prime but not odd? 2. Which numbers are odd but not prime? 1. And that's it. Now let's look at our both, the intersection. What numbers are both prime and odd? So the numbers that are both prime and odd, we have 3 and 5. So to calculate this probability of prime, let me do it over here actually. So calculate the probability of prime, or, I think I said and before, so prime or odd, that's going to be equal to the probability of prime plus the probability of odd, and subtract away the probability of prime and intersection odd. So let's calculate the probability of a prime number. Well, for that, if we're using the Venn diagrams, we're just going to count everything in that circle. We have 3 items in that circle. We have a total of 6, so 3, 6 over 6, plus odd, we're going to calculate or count numbers, the items in that circle, which is 1, 2, 3. So that's 3 over 6. Let's subtract the items in the middle. We have 2 items there, So minus 2 over 6, well, that gives me 6 over 6 minus 2 over 6, 4 over 6, which reduces to 2/3. So the probability of rolling a prime or odd is 2/3. Now, last thing with your Venn diagrams, if you're looking at the entire universe, quote unquote, notice that I didn't write all the numbers down. So for this Venn diagram, everything within the circles satisfies the given criteria, but we also have that 4 and 6. So that would be the complement, the opposite of what we're looking for. Alright, last example. So this example states that we're going to use the Venn diagram to help solve. We have 220 people came into the Italian deli on a Friday, 104 people bought pizza, and 82 used a credit card. Now, half of the people who bought pizza used a credit card. What's the probability that a customer bought pizza or used a credit card? So we're looking for the probability that a customer bought pizza or used a credit card. So just from the question alone, we know that this would be a mutually inclusive event because you could buy pizza with a credit card. So both can occur at the same time. So we're going to have to look for the probability of buying pizza, add it to the probability of using your credit card, and we're going to subtract away the probability of buying pizza with and using a credit card. So using our Venn diagram, we know that we have 220 people total. Now the total number, so if this whole circle here, I guess it's not a circle, oval here, is buying pizza. Well, that side of the Venn diagram has 104 people because this whole oval represents buying pizza. On this side of the Venn diagram, that represents the people who used a credit card. Well, the total number of people who used a credit card was 82. Now it says that half the people who bought pizza used a credit card. Now that is going to be represented right here. So this is where both are occurring, or people who bought pizza with a credit card. Well, if half the people who bought pizza use a credit card, we do 1 over 4, split that in half, and you get 52. So we had 52 people who bought pizza with a credit card, and we have 52 people who bought pizza without a credit card. So this portion represents people buying pizza without a credit card. This represents people who bought pizza with a credit card. And then if you had 82 people total using a credit card, well, if we do 82 minus 52, because that represents people who bought pizza with a credit card, that would give us a remainder of 30. So out of the total of 82 people who used a credit card, since 52 used it for pizza, that leaves 30 people who use a credit card for something else. So there's our Venn diagram. Now how do we use that to calculate the probability? Well, first, let's calculate the number of people who bought pizza total. Well, that's this entire part of the Venn diagram, which is 104. So we have 104, let me use a different color, 104 over the total, which is 220. And we're going to add that to the total number of people who used a credit card, which is this entire oval here, this entire side of the Venn diagram. Well, that's 82. The total is 220. Now, how many people used their credit card to buy pizza? Well, 52. So we're going to subtract away the repeating, the double counting, the 52 out of 220. Well, that is going to give me $186 over 220 minus 52 over 220. So minus 52, that's going to give me 134 over 220, which simplifies to, let's see, let's divide by 2, 67 over 110. So that's the solution, that's the total, that's the probability of buying pizza or using a credit card, is 67 over 110. And that's it. Email me if you guys have questions.